The first one is by Naresh Kundri. Second is by Mr. A.K. Lal. Third is by Shaili. And fourth one is by Rajbir Chaudhary. And the last one is by Mr. Sandeep Mittal. So let's start one by one. So first I request Dr. Naresh Dubey. He is from Bangalore. He is in continuous improvement and marketing of KNAUF Selling Solutions Private Limited, which is a global leader in a design and manufacture of selling and has a combined history of more than 160 years, offering innovative interior solutions that helps to enhance the comfort, save lives, improve building efficiency, overall performance, and creating building space. In April 2020, his group completed its acquisition of Armstrong World Industries. In this role, Mr. Naresh Dubey is responsible for driving a KNAUF India business for healthcare, for the education, merchandise, and marketing. He is passionate about transforming where kids learn in schools and patients head in hospital. Mr. Naresh Dubey, he brings this industry his broad expertise in the consumer during and IT section. Before this role, Mr. Dubey worked with Ingram Micro as marketing manager for IBM, ranging of products. Mr. Naresh Dubey started his career at Odisha, where he worked as a product manager. So now I request Dr. Mr. Naresh Dubey, please have a comfortable talk. So audience is available. Online. So it is online. Attachment attachment. And video. Hello. Hello.
You able to hear me now? Okay, so I joined from my laptop and mobile both. Is it okay?
Yes, sir. Please go ahead.
Mr. Garg, can you hear me?
Yes, sir. Yes, sir.
So great. Thank you so much. Thank you for the patience and technical glitches. And this is Acoustics seminar. So listening, this is a demonstration as listening is as important as seeing each other, right? So uh, let me share some of these case studies and the work I have done. Fortunate to contribute over last decade in the space of education and healthcare, like it was said in the introduction. So noise control and building acoustics. So my expertise would be in the building acoustics purpose. I was part of a National Building Code Committee with BIS, and I'll share the detail out here, and also ask some basic thing that how can we improve the quality of life? How can we really impact uh, the difference in the way our buildings are constructed and used going forward? So without further ado, this is who we are, and I'm not going to spend much time on it, but we are one of the world's largest construction company with more than 14 billion euro turnover, globally presence with largest manufacturing footprint uh, with 40,000 employees currently. The 35,000 was last year. This is one of the largest group in construction. This is a short introduction of different kind of projects we have executed across. So when it comes to materials, we have every possible solution you can imagine for walls and the ceilings. And acoustics and aesthetics are our two basic hallmarks. So metal, mineral fiber, soft fiber, wooden, and this is like a Ranchi railway station metal ceiling. We are working with transportation, healthcare, education, hospitality. You speak about the space ceiling application is there. Armstrong Knauf Ceilings has more than 70% of global share of ceiling business when it comes to acoustical solutions. Knauf as a group also have a large company on the chipboard manufacturing and insulation part of it. So those are two different groups under Knauf umbrella. So these are some of the. This is a recent project in Bandra for Tata Consulting Company. So we have an experience which is combined experience of more than 160 years globally with all kind of materials. This is wood particle board, soft fibers, and auditoriums, cafeteria, education institutes, and things like that. So this is just a preview of a range of projects we have executed across the world out there. So this is the National Building Code we are talking about. I'm part of, and we have a quite progressive National Building Code, and 0.6 seconds for 0.6 seconds for the classrooms and 0.5 seconds for the school where the physically challenged students are there. It's a nice code to have, but the real challenge is in implementation of this code as such, because currently what we have is 99% of the schools are not even designed considering sound, which is a serious affair. So having a code and not being used is as good as not having a code. Am I right in saying that pretty humbly? So we as a group here and this particular international conference has power to transform the entire education scenario, provided we make sure that this is implemented in the right spirit across the state government and private schools. This is a global global code around acoustics, and we are very much there. If you really see, we have we do not compromise on that, so we are there. But another important parameter is there is additional parameters on a background noise. So background noise is a function of location. It's function of designing, whether you have a school windows facing traffic or you have a back wall design. But currently, if I would not, it will not be arrogant if I say none of these architects are really considering sound as a parameter while designing a school building. Forget about any other institute. If in the schools we are not considering sound, where else it would be? And the new rating systems and the golden points on sound and acoustics is going to be a next norm as we move ahead in our society. Now, this is a study done over 60,000 respondents post-occupant. The green indicate the lead buildings and blue indicate non-lead building, 40,000 for lead and 20,000 for this. If you see, green buildings are far better when it comes to furniture, thermal comfort, general satisfactions, air quality. Lighting, green building, people not really happy, maybe because of a lot of glare and glass. But across 60,000 respondents for green and a non-green building, okay, so CBE Berkeley did this survey. People are not happy. And surprising fact, which we all should notice, the green building, people are more unhappy about sound. So, typically daylight is given a lot of importance, and hence a lot of noise comes around when you open the spaces, and also glass being used which reflects sound. Now, this is some critical observation that as a community, as human, as a race, we are not paying as much attention to sound in our buildings. Now, it is great to have rating systems and given whether it is IGBC, LEED, you name the thing, it is all about carbon footprint, is about energy conservation, and these are the great thing to do because they make our earth sustainable. Please do not misunderstand that I'm undermining it, but there is a purpose why we are putting up a building. The mission is so important. Why we are constructing the buildings? Buildings are designed for people. And don't you agree with me? So post-occupant survey, the functionality, productivity, and the purpose of the building, what drives the thing. Now, let me take an example of school buildings. You and I and our kids been to the school. Mother is telling kid, please go and sit in first two rows. If you sit on a back bench, you'll be losing out. And kids are also going for the classes. But what is happening to the teacher? If you have anyone friend who is a teacher, first two classes, they're effective, and then they hardly teach. So either they speak at very loud voice, or very fast. Now, if somebody comes to you and speak at 60 decibel, 70 decibel all the time, where is voice modulation and where is communication? So our focus has been how good is the curriculum, how good is the teacher, but real fun or real purpose of education is connecting between teachers and the students. And when like I can deliver my performance best when you're listening to me, and that gives immense satisfaction. But if I have to just deliver as a motion, shouting every single day, imagine what could be happening to his physical and mental health as a teacher. And anyway, the teachers are the people in the most of the institute who could not find a sizable job. So this kind of affair exists because one single important factor like sound is not being paid importance in this country for last 70 years. And this is not an allegation, this is a fact. We started education under the tree, which was the era which we migrated from. When we moved into a good solid concrete building, we've forgotten about designing for sound. And that's the way we are landed into where we are. We have a very high performing education system where a lot of people are not getting any education. They're just getting degrees. Can you hear this sound? Sound is audible from the video?
No. No. No.
So this is how 1.5 seconds sounds. So the same room, when it is treated with, I'll just mute my machine. So when it is treated with one surface, the acoustical performance so when it is treated with one surface, you can experience difference between 1.5 and 0.5 seconds on the screen. So these are case studies from Kendriya Vidyalaya Light in Delhi. Uh, So our kids are learning sound and a basic language, in a place where they are not able to understand what is being said, and why we are not noticing these reverberant spaces in our schools or higher education. Any idea? Anybody wanted to really explain why this is not being noticed? This 2 seconds, 1.5 seconds kind of reverberation. And there are mathematical models and there are apps available to calculate this. We don't need to be a scientist to really do that. We can experience it also, like I demonstrated you on the audio. But there are like thousands and lakhs of teachers going to the institutes. Why are they are not noticing any reverberant noise? Can anybody share? Why do you think so? Okay, and the reason is background noise. Because the reverberant noise is camouflaged by a background noise. Reverberant noise get added into the background noise with a log. So you have a buildings, concrete buildings, which are reverberating with 3 seconds and 2 seconds kind of sound. And whatever the background noise coming into that building is further getting added to the original sound. And certainly what is the outcome is dysfunctional education institutes. So when we did this study with a control group versus a non-control group, the grades improved dramatically. And what improved more is for languages. Let's say if you are teaching in a class which is 2 second reverberant, and if I say hi, how are you? Fast enough in 2 seconds when I say you, hi, still in the air. So clarity between the words is diminish. Clarity within the words is also diminish. And when I'm not clear, as I said, I tend to speak loud. I tend to speak faster. So human ear has a faculty to distinguish a sound when it is more than 0.5 second delay. Below 5.5 seconds delay, we cannot see a difference between the first sound and second sound. That's about human ears. So we need to really see what are we designing our spaces for. And once you do that change, and you don't need a BNK instrument and all those things. We have very professional apps available right on your mobile phone. So I'll share a link with you all with the email after the event where you can download this app on your mobile phone and get more sensitive about what is the background noise level, what is the reverberation time in the space. So global norm is with furniture, door, window, close, kind of a classroom to test the reverberation time because that's the one test condition you can maintain across the buildings. So what get major get improved? Can we do something about this? Can we really implement National Building Code? Can we really insist on having sound as important, if not more, as fire or safety norms for any education institute to get a permission to admit students and teachers? And that is where we need to move as a community. So these are the instrument, BNK instrument used along with the Joost engineering support for doing study across 2025 institutes last time for National Building Code. And if you see now, these buildings did qualify the current National Building Code norms. You know why? Because none of these classrooms were designed for it. All this is right. So when we treated only one surface with average NRC of zero point 0.6, zero point 0.5, most of them do qualify, but the larger room of 600 meter cube kind of thing requires some wall treatment. And Signal School, which is the platinum rated lead school, has a lot of glass. So glass reflects sound. But I need to draw attention of you all scientists toward one important factor that when we reduce reverberation time, see a significant reduction around 8 to 10 decibel on BNL. Now, 10 decibel less is half loud. It's a different environment of working condition for, for our kids. Be in 10 dB less louder environment. And for a teacher, it's a different environment to speak and communicate when you are working in 10 dB less sound space. He did not need to shout. He can reach to the last bench. His voice is very clear. And we'll see some cases around this. I'll skip this. This I discussed yesterday about materials. So materials may look same, but it may not. So if the same looking thing, so these are the BR student who gave changed the material and So you can see the difference between just a clap. Yes, you can be very benefited with using right testing in NPL labs, but you can just change one aspect, and for the material, you can really see the difference coming in. And this is another case study. This is where the major action happens.
Your voice is not audible. Sir, please try to wind up this movement. Now you're on.
Like we can take a question and answers. We have a lot of case studies around. And our YouTube channel or social media channel is available to see all these case studies. We have case studies with Delhi government schools, case study with JJ College of Architecture, which is 150-year old institute where it is done. So I need to draw two important points out here is one thing is building consciousness around sound and acoustics in our society. It can be done through a codes and standards, and like we have penalties and things like that. Can we really have one single institute where 25 or 50% of the people are spending time in education institutes implementing the national building code? So can we really do something around that?
Sir, I have just one question, sir.
You're not audible for me, sir.
Hello, am I audible, sir? Hello.
And second important point, if you can hear me, can you hear me, sir?
Sir, we can hear you, but are you able to hear me? Hello, are you able to hear me?
Yes.
So I have one question actually. Narishi, actually we have both the tiles in our level. Even the mineral fiber also and calcium silicate tiles also. And I think there is not much appreciable difference in the NRC value for both the tiles. Maybe that may be there. Definitely mineral fiber has good acoustic properties. But does that matter a lot when, because you were telling that calcium silicate tiles when you change, so there was a very appreciable dip in the RT measured by.
Thank you for this question. And see, we have done independent test. No, I take care of Asia business for our continuous improvement. And nowhere in any other country across the world, calcium silicate give acoustics than India. I would really request you to pick up material from the market. It's a stone. And stone just having some aesthetic performance or some texture on the surface as a material cannot really give as good acoustical performance as soft fiber or mineral fiber. If somebody is claiming those values, it should be really checked up. Because if that is happening, entire world will manufacture that kind of product. So it's the property. So what we did is we just change one surface in a room without changing anything else and measure the value with the same instrument before and after. And I did that in N number of institutes in Surat, in Delhi, in Kolkata, in Bhubaneswar, everywhere the same results. Because it's a harder material. The harder the material, more the reflection, softer the material, more the absorption. It's like extremely common sense. So at the max, when we tested this in Pune lab and some other lab, we got 0.2 or 0.3 on those material when the claim is 0.7 and 0.5, which is completely wrong. And where NPL can do the test independently, you can pick up the material from the market, not from any of the manufacturer, and test it independently, because that will put a Bible and that will give a foundation for CPWDs and government bodies who is using it for water resistance. So
Sure.
Water leaking building is a different problem than acoustic thing, and we need both solutions.
Sure, sir. We will try to test these materials in our lab. Thank you again, sir. Thank you for any questions. Okay, sir. Thank you, sir.
Okay, thanks, Mr. Naresh. So you have given a very good talk, and it's relative to we people also. I am from Educational Institute. So we see all these effects in the class in a big size also. So in a class of 400, 500, so their acoustics matter. So how much it is audible or it is a problem. So okay, so you are I have listened to your all efforts which you are doing for maintaining the acoustics and to hear the sound clearly, so that students can enjoy the classroom teaching up. Thank you very much. Thank you. So our now I welcome the next speaker, Mr. A.K. Lal. He is from Ahuja Engineering, Delhi. Mr. Ahuja, he graduated from BIT Planning. He has 45 years of experience in audio and television industry. He is specialized in research and development of loudspeakers and microphones, and he has widely traveled in China, Southeast Asia, and Europe. Currently, the technical director of Ahuja Radio, India's largest manufacturing export of public address equipment. Currently serving as convener of the panel of audio standards of the standard. He is a member of BIS division of Councils of Electronics and IT section. So now I welcome Mr. Anil Veera.
Can I have that? Good afternoon, gentlemen. As the chairman has already introduced me, I am Anil Lal, Technical Director of Audio Reviews, and presently convener of the BIS panel on audio standards and the BIS Governing Council on Electronic. This workshop is strictly on building materials and building code, but I think I have the permission of the organizers to take the subject a little on the side, a slightly different subject, namely noise pollution and its control in general. Some of you may think that public address systems are a great cause of noise pollution. Abuja Radios has been making public address systems amplifiers with our amplifiers, mics, and loudspeakers since 1940, 82 years. And we export to 52 countries, including developed countries like Germany, England, France, Italy, Spain, Australia, Singapore, Norway, apart from, of course, Africa and Asia. So is public address really a nuisance? Public address systems, are they really a cause for noise pollution? Public address, by definition, is meant to deliver sound where and when and where it is wanted. If somebody is delivering sound where and when it is not wanted, it is a misuse of the system. Sometimes I travel in the metro, and so many people in the metro are sitting using their phone to see movies or videos or YouTube or whatever. Most of them use earphones, but some of them don't. On several occasions, I've had the misfortune to sit next to a person who's watching a movie on the cell phone without any earphones. It is so irritating. I feel like getting up and finding another place. But it is not the phone which is at fault. You can't blame the phone. There's the fault on the phone. It is a person who is not sensitive to the subject of noise pollution, who doesn't realize what he is doing. Public address systems are used in a lot of essential applications. Very simply, this conference could not take place without this. The fire alarm and emergency evacuation system, auditorium, staging, crowd control by police, etc. Conferences like this, in educational institutions for teaching, if you have 400, 500 people in one classroom, the same. You need these things. In religious places, yes. So long as you are using it properly in the religious place inside, or a church choir or for bhajans in the temple is fine. Yeah, start putting on speakers outside and making a noise. And I would consider it a misuse. Restaurants, airports, railways, without PA system, you can't have any. Marriages, music shows, this is the most sensitive point when it comes to noise pollution. Marriages and music shows and political meetings. Our sound systems are used in the Kumbh Mela. Thousands and thousands of speakers spread over 56 square kilometer area. And I was told by the organizer that 600,000 announcements were made only on the subject of lost and found. Children lost, bags lost, property lost, whatever. In a typical Kumbh Mela, 600,000 items or people are found after being lost because of use of public address. But when we come to noise pollution aspect, several questions must be carefully thought out. Why the user? Why the owner? And I am the first, most frank in saying that first you should ask, is the PA system required at all? Why generate sound unless it is necessary and there is no alternative? As I said, people are not sensitized so much to the problem of noise pollution. At huge cost, there are these newly made tunnels in Delhi, underground road tunnels, under Pragati Nadan near Kerala. I was going, it's just been built a few months back. I was going through it, and they put big speakers, horn speakers all around, very expensive imported speakers. And they keep on making pre-recorded announcements. Don't drink and drive. Don't smoke in the tunnel. Again and again and again. I mean, my question is simply, could you not put up visual display? इतना लाउड है सब किसी सुनाई देता है डिस्टर्ब करता है आप म्यूजिक सुन रहे हो आराम से कार में जा रहे हो सोच रहे हो and again the same message. Don't smoke inside the tunnel. Don't drink and drive. I mean, wonderful announcements, very good. But can you not have displayed it visually? Nowadays, LED displays, all kinds of illuminated displays are there. They will attract equal attention and cause less irritation. For that matter, I am not criticizing anybody. I'm sure experts have considered the matter, but I'm just raising food for thought. People who travel in the metro every day, at every station announcements are made inside the train. Please mind the gap between the train and the platform. And the next station is this, and this station is this, and doors will open on the right. I mean, in a typical journey, you hear the message 10 times, 15 times, 30 times if you are coming back also, 30 times a day, 900 times a month. Can't they do that through visual displays? I mean, how many people travel in Delhi Metro who don't know how to read and write English or Hindi, at least one of them? Every bogie of the metro already has 4 displays. Or you put 8 displays. You put 10.
But sir, it's true all over the world. All metros.
I'll come to that. I take your point. I come to that. It's also all over the world at stations and airports. I'll address this. I'm a manufacturer of public address systems. I love it. Similarly, at the metro station, you will be told everything. The train is coming in 2 minutes, 8 bogies, whatever. They already have 2 or 3 LED displays on each platform. And the platform is not very long. Instead of 2 displays, you can have 4 displays. You can have 8 displays. So there would be 1 display near each bogie. You have to make an audio announcement. And in answer to your question, sir, I do believe that many airports are now planning to go back. All these things, we do whatever is done in Europe or whatever is done in Japan. But all these things were implemented initially in Europe or the US or Japan at the time when consciousness about noise pollution was very low. 20 years back, I would not have raised this point. I would have gone by what he says. That is the common practice. This happens every day. So these things, these rules, these procedures were made at a time when so much consciousness about noise pollution was not there. Today, I am told several airports are planning to go silent very soon. Announcement system will be there for use and everything. But there is no need to make routine announcements because visual displays are there. You have as many visual displays as you like. So, I mean, this is food for thought. I'm not saying visual announcement is wrong. I'm just giving an example that you need to think carefully. Then what is the appropriate equipment? And then how to install them. Proper use of the public address system will only happen when the second and third point is also addressed. As an example, I am, say, a sales girl in a shop, or I am a shopkeeper in Tarolbagh, and I want to sell my products to all of you who are walking by. I can use a megaphone like this, which will be heard 100 meters radius. In China, this picture is from Guangzhou. If you do this, you'll end up in jail for that. What they do is they use an appropriate equipment. The equipment is hanging here. It's a small paper cone speaker. speaker and a small 1-watt amplifier hanging here, this kind of a system will be heard only by about 5 people on this side. It certainly will not disturb the people working in offices. So this is what I mean by appropriate equipment. You are all familiar with these horns. At every public meeting, religious places, schools. I have a school maybe half a kilometer from my house. And at 8 o'clock every day they have their assembly. And we can hear everything inside our house. This is a typical way horns are mounted. But it's a simple fact that horns are very directional. For a typical horn, here the red pattern is at 1 kilohertz. Even at 1 kilohertz, at an angle of 90 degrees, you get an attenuation of about 12 dB. Even at 45 degrees, you are getting an attenuation, almost the same, 12 dB. Now see what is happening here. The horn is put well above our height, facing there. Most of the energy is just going into outer space or is being directed at the houses nearby. What the person here is getting is already attenuated by 12 dB. And the high frequencies will be even more attenuated. So clarity and intelligibility will be completely lost. But 10 dB, 12 dB is a lot. I mean, maybe you don't need a 40-watt speaker, you just need a 4-watt speaker, but directed at the audience. The horn has to be tilted towards the audience, not directed out there. And this is a mistake so many places I have seen. I would venture to say that half the places where I have seen horns installed, they are installed like this, including railway stations. This is another company, this is a Bosch, a horn speaker of Bosch, which again you will find as a very directional pattern. In fact, if you see the horizontal opening angle at 1 kilohertz is about 55 degrees. That means only about 22.5 degrees here, 22.5 degrees here. So there is severe attenuation at 45 degrees and 90 degrees, and mounting a horn facing there just doesn't make sense if the audience is here. Now, how to solve the problem? One, of course, so have a directional source and point it at the audience. Most speakers, if I take a box speaker, I will treat these as box speakers. A typical box speaker kept over here is an almost omnidirectional. It sends sound out in a spherical pattern. Or if you keep it against the wall, it's a hemispherical pattern, but still the sound is spreading out in a spherical pattern. And as you all know probably, the sound attenuates as the square of the disc. The air does not absorb any sound, but it is simply the area. Since a spherical waveform is going, and the area of a sphere is proposed 4 pi r square, and the same sound is spreading over a bigger area. As you go further and further away, it's a bigger and bigger area. So because of that, the intensity of sound at any point there will be inversely proportional to the square of the distance, which translates into a 6 dB attenuation for every doubling of it. On the other hand, if you have a line source or a cylindrical source, the waveform, the area of the cylinder is proportional to R, pi RH. So the sound attenuates in direct proportion to the distance. In other words, the attenuation is just 3 dB for every doubling of it. And that makes a huge difference. I mean, if I am playing a music program, dance music, marriage kind of program, and people love music and people dance and they want loudness, and I have to cover an area of 60, 65, 70 meters. With a source like this, box speakers kept one on top of another, I may need 1,000 watts of electrical power. I need to generate 130 dB here to be able to get 80-85 dB there. But if I have a good directed source, I can manage in something like 113 dB. This is almost 20 dB down. So you don't need anything like 1,000 watts. Now, how to achieve this kind of a line source? A typical thing is a column speaker. You have these here, but these are very small. Speaker of this length will not qualify as a column. And these are actually recommended. IS 1881 Code of Practice for Indoor Installation specifically says column loudspeakers are ideal for obtaining the vertical. You can't read this. IS 1882 Outdoor Installation of PA System Code of Practice also says the height and inclination of loudspeakers shall be so adjusted as to their maximum satisfaction. Now, in a line source, what happens? You have to have a very low spacing between the speakers. The spacing between the speakers should be ideally less than lambda by 2, half the length. And the overall length of the column speaker should be 2 to 3 times the wavelength you are trying to cover. This essentially translates as a typical example. I will not waste time in translation. If you have 4-inch speaker, the 100 mm speaker, from the center of one speaker to the center of another speaker, you will have 100 mm separation. And if you have 8 or 12 of these, you will exceed 1.5 meters in overall. Then it becomes a real line source. The sound will not attenuate at 6 dB for every doubling of distance. Ideally, it will attenuate only 3 dB for every doubling of distance. Ideally, you will not achieve the ideal, but you will certainly achieve less attenuation than 6 dB. At most, speech treatment. These kind of columns are largely used for speech. So we are talking of the frequency range around 300 Hertz to 3 kilohertz like that. But again, the column has to be mounted like this. It has to be mounted slanting. If I mount a column speaker here, it has to be slanted towards you. It's not to be. The line source is not to go above your head. So unless I use proper hardware and tilt it towards you, then the line, the linear waveform or the planar waveform will go here. Of course, if I mount it there, it will go over your head and you will only get something which is coming down like this. What, if it's facing there, what will come to you will be very garbled sound and very low sound because the attenuation in this direction will again be something of the order of 10 Sorry. Now here I have taken company to Japanese company is one of the topmost companies in America. And for their column speaker, they give a directivity angle, horizontal 90 degrees, vertical 0. That means if the column speaker is kept like this, the sound here and here is 0. The whole thing is beamed like this. The vertical dispersion, they have actually specified as 0. But that shows the importance of mounting it properly to be tilting at the center of the body. I have seen column speakers at Indian railway stations, at metro stations. It's rarely tilted. It's almost always mounted high on the wall. You have to mount it high on the wall, otherwise somebody will tamper with it. And it's facing above everybody's head. If you use it properly, you could probably have used 1/10 of the power. Our company has done a lot of work for Delhi Metro. And at several stations, at Dwarka station, I talked to the engineers. I said, why is your volume setting so low? I think you can't make out what is being said. And they said, sir, kya kare last time, neighbors, you can call me. See, most of our metro stations are not underground, they are overground. And if you have noticed, they are semi-open. They are not really indoors, they are like a corridor, open from the sides, open from the ends. And the metro engineers told me that there is a lot of disturbance, the neighboring colonies object to them. This is why I come to your question. See, just because something is being done doesn't necessarily mean it is desirable.
I meant the safety announcement.
Yeah, of course the system will always be there for them. Now, when you are doing dance music, marriages, discos, column speaker is not enough because, as I said, it doesn't work below 300 hertz support. You can't do with 100 mm of audio. For these purposes, big speakers I use 300 mm, 12 inch, 10 inch, like that, 50 mm types. So, what has come up in the last 10 years is what is called a line edge. I'll show you another picture. See, a line array is made up of a number of different boxes. And again, the principle is same. Now, this particular line array has two woofers for low frequencies and one tweeter for high frequencies. Each of these is a separate box. Two woofers, one tweeter. So the high frequencies and mid-high frequencies are through the horn tweeter, which is itself direction. I'll talk about horn tweeter separately. The woofers concentrate on the low frequency. So again, if you say you take half wavelength separation between speakers, if you use a 10-inch speaker to 50 mm, the separation between the two is 250 mm. And if you have 8 or 10 of them, your overall height will go up to 2.53 meters for the whole array. So you are able to get a separation between speakers less than lambda by 2 and an overall length greater than 3 or 4 lambda. So the whole thing becomes a line source and it's highly directional. If it is tilted properly, but it is always hanged from a high point, tilted towards the audience, each box can be individually tilted. It also gives you uniform frequency response and uniform loudness everywhere in the area. It's not, if you put a box speaker here, you won't be able to sit close to it. It will be too loud, and the people at the back may be demanding more volume. But with a line array, first of all, you have a beaming, so you don't have 6 dB attenuation for every doubling of distance. Secondly, you have some speakers facing here, some speakers facing there, and you can reduce the volume of the speakers which are facing here. So a lot of good can be achieved and a lot of directivity can be achieved. And I'm stressing this because mainly people perceive public address systems as a nuisance because of marriage parties and dancing and which is common in our system. But again, if you use proper equipment, you can achieve a great deal of directivity. And the horizontal dispersion is about 90 degrees, so 45 degrees here, 45 degrees here, at 6 dB down. At this, again, it will be 12 to 20 dB down. So it doesn't disturb the neighboring houses, the neighboring colonies. The vertical dispersion is almost zero. So if any multi-storied buildings are there in front, nothing is going to. The vertical dispersion is close to zero. This is again the same thing. Horns mounted, triangular race course. Horn speakers mounted up on the ceiling facing there. This is a very prestigious program at one of the most prestigious locations in Delhi at the India Habitat Center, Central Lawn. They are using a line array. Ulta. It has to be hanged from a height and directed at the audience. You are directing it at the offices in front. I mean, I have seen this happening at a government-sponsored musical program in the central lawn of the place. It cannot be a small party who is doing it. See, these equipment hires, they claim we have line arrays, we have this, we have that, and that, and generates respect and enables them to get their charges. But very often it is not used, in which case it will create noise. This is what I meant in my first or second slide. That public, it is misuse of public address equipment. which causes noise pollution. Now, we already have standards. We already have standards for installation of public address systems, indoors as well as outdoors. But I have proposed to BIS already, and these are being taken up for review, for improvement, updation. Because again, these were made a very, very long time back in the 1980s, when noise pollution was not the subject. The standard deals with more things like connectors, cables, such code of practice. Today, if you make a standard, you have to put in these kind of things. Use of directional speakers and their mounting has to be recommended. And why not sound absorbing materials? See, if somebody does a Shadi Barat program in his colony on the road, they don't just sit down on the road and start having. They always put some partition, some whatever. They partition off the area. Why not use sound absorbent panels? I'm not worried about the capital cost. I know they can bear it. A capital cost of 10 lakh rupees will be no problem for these equipment hires because they already have equipment much more than that. And they are not buying the sound absorbing material for every event that's ready. They buy it once in 5 years or something and they spread the cost over 50, 60 beds. But the problem again is knowledge. I'm 100% sure they wouldn't know what to put, where to get it. That is where government agencies like NPL, BIS, others can play a role. In terms of training, in terms of publicity, in terms of standards, that this is what you will buy. And maybe have some leaflets with recommend actual types and actual costs and so on. It can be done, but somebody has to do it. Then sound level meters, the noise pollution rules specify what should be the noise level in each area. And the police is now having, I know they are having a lot of sound level meters. The Deputy Commissioner of Delhi Police told me, Mr. Lal, we have placed an order for 200 sound level meters. I said, sir, I have only one question. The guy who's hiring out the sound equipment and the person who's paying for it, or even a big organization which is getting a sound system installed, they don't have a sound. It is something like, I don't have a speedometer on my car. I don't know what speed I'm driving at. And you policemen are standing there with a laser gun. Hey, Mr. Lal, we're going to find you. You can do that only after I have a speedometer in my car. Now, if the sound equipment hirer doesn't even know anything about the sound level, he has never measured sound level. He doesn't even know what sound level he is supposed to be maintaining. How can you go around arresting him or seizing his equipment or that? This is the question I pose. Again, it comes to a question of training, to publicity, to creating awareness, workshops. See, any big campaign starts with the family planning campaign in the 70s and 80s, then the anti-polio campaign, then the government campaign for COVID awareness and COVID appropriate behavior. Nowadays, the Swachhta Abhiyan. Thousands of crores are spent. TV ads, newspaper ads, any number of people going around publicizing. How much have we spent, either in terms of money or in terms of effort, on awareness on noise pollution? And I'm sure, I can just give a few ideas, they may not be right. But if a panel of experts works out, I'm sure we can find very economical ways of creating awareness about sound pollution. For example, this may not be the best idea, but I'm giving you what I'm. How many sound equipment hirers are there in Delhi? How many marriage halls and hotels are there in Delhi who have marriages and that disco type dance music? Few thousand, 2,000, 4,000. And everybody knows who they are. But the concerned police stations know, everybody wants. We know. It's just a question of conducting some pre-training camps. Just 1 or 2 hours lecture. all of them, not 4,000 at one time, but maybe in groups of 40. People like me, I volunteer my services for explaining the technical aspects of this. Somebody from the police should come. The police uniform is very important. I'm saying you should not do this, doesn't count. But if a police officer comes and tells them, hey, look, you have to have a sound level meter, and if you exceed 35 dB on the road, please keep your equipment. At least tell them first. Now, this is where the role we can all play, but the government association is very necessary to create awareness. And if you want to have a low-cost campaign, you have to have focused campaigns. You can't use paper, TV, and all that stuff. Maybe that also. But it's possible to do it in a much smaller way also. So to implement any noise control in general, first of all, you need an engineering solution. And the purpose of my talk today is to say that many engineering solutions are already available. You don't have to discover anything. The public awareness has to be created, and official involvement is a must. But official involvement doesn't necessarily mean a danda. That the police go there and, I'll seize your equipment and go down the program. It can also be in a gentle form of creating awareness, distributing leaflets, training camps, etc. Now, a few thoughts. Some of this may be controversial. We have sirens installed on all ambulances and police vehicles. Of course, that should be done. I'm not at all against. But the people who buy this equipment, whether it is police forces or hospitals, do they have any acoustic experts realizing that not? Hello, this is still working. Your battery may be down. Not very names they connected.
कोई तार है क्या? वो आप बात करते रहो. So you can speak. You're talking about ambulances and police vehicles.
What you need to have, first of all, is an awareness about the appropriate. The general feeling, according to me, is the louder the better. So giving me a 10-watt siren for this cost, or you're giving me a 20-watt siren for the same cost. Want to buy that? Now, again, aping the West is just doing what Europe is doing on the land. Needs a lot of thought. I have myself seen in Germany. The traffic density on the roads is so low, something like inside NPA, that when a police vehicle comes with a siren, totally 5-6 cars are there, they all shift to one lane, and the police vehicle can race forward in one empty lane at 100 kilometers an hour. That doesn't happen in any Indian city. It happens even less in small towns where the traffic congestion is even worse. Nor do I consider it desirable for a police or ambulance vehicle to drive through at 100 kilometers per hour, even in the middle of the city. You have potholes, you have speed breakers, you have dogs running across the road.
You have human beings working.
Well, human beings hopefully will hear the siren, but not the dog, not the potholes, not the speed breaker. I mean, imagine somebody has had a fracture and to drive him across the speed breaker at 100 kilometers per hour. It's not desirable. The purpose of a siren in an Indian emergency vehicle, according to me, is to get the vehicle out of traffic jam and let them jump the red light and go on. I don't see the reason why the siren needs to be heard at 1 kilometer. It's just that if there's a traffic jam, the 5-6 vehicles ahead of you move aside. Or if there's a red light, you're allowed to jump across. Something like that. Also, it is true that police likes to have the siren audible at 90 degrees angle. It is because of crossroads. When you come to a crossroad, there may be vehicles coming from this direction. So there's no need for the siren to be heard 1 kilometer in this direction. When you are already at a crossroad, it will take you 5 seconds to get across it. If 5 vehicles here and here can hear your siren, It's enough. So the siren has to have directivity according to me. But in not a single tender from any hospital, government agency or police department have I seen directivity being specified. Everybody specifies the minimum sound pressure level. Nobody specifies the maximum. Then again, frequency. Typical Indian sirens fluctuate between 300 Hz and 700. It's a fluctuating frequency, 300 to 700. There is nothing sacrosanct about it. It is again copying the West. जो यूरोप में होता है हमने कर लिया या वो Chinese whatever they are exporting we are importing. If you can go to higher frequencies 2 or 3 kilohertz, you can make the directivity much higher. I mean, a police vehicle is going this way. Why do you want to disturb the neighboring housing societies, the neighboring flats and shops and offices? Why does the siren have to be heard 1 kilometer in this direction?
Yeah, I may be wrong, but I believe the standard is between 800 Hz and 1.4 kilohertz because your human ear sensitivity is
As high as 2 to 3 kilohertz.
800 to 1.4 kilohertz.
But it is actually your human ear sensitivity is highest to 2 to 3 kilohertz.
1 kilohertz in India.
3 kilohertz. Okay. Peak, I think, is at 2.2. My only point is that is a secondary consideration. Should be. But if you can go to 2-3 kilohertz range, you can make the siren much more effective. But who will touch the subject? Who is willing to change it? Again, the same kind of answer will be there by siren authority. So this is like I was illustrating that when a vehicle is going, it needs to be heard as that was deadly. But it can be a highly attenuated sound on the side. You don't have to be heard. Now these types of sirens, that one looks very nice, very smart, very modern, but obviously a very small source of sound in the metal. This is going to be almost omnidirectional. These type of sirens are almost actually omnidirectional. These types of sirens are omnidirectional. But the moment you put a horn, you can start giving some light. This is just food for thought, sir. I'm not at all in a position to pass judgment what is right or wrong. The rectangular horn, 275 mm by 200 mm, that means about 8 to 10 inches, gives a 6 dB attenuation at 45 degrees and a 15 dB attenuation at 90 degrees. This is, I think, a curve from the leading manufacturer Bosch. So the technology is there. You don't have to invent anything. You have to create a way. This is our own company's horn speaker. Again, the red is 1 kilohertz, and you will find this attenuation of about 12 degrees. 12 degrees at 90 degrees. That is what is required. So the technology already exists, provided the user and the buyer has the awareness. Okay, quickly I'll go through. The same thing about vehicle horns. We typically use a horn like this because that's what the world uses. But the world doesn't have a problem of everybody going and blowing the horn one after the other. I mean, that's an Indian problem. So, while any modification to the building code is most welcome and put it on it, certainly we should do it, certainly we should stay with time. But again, food for thought. How many of people in India live in air-conditioned buildings? 99% don't. Which means the windows are always open. So, doesn't matter what the walls are made of, the noise pollution from outside is going to be. We are all well-educated people. We may be having air conditioners in our home. But do you have an air conditioner in your kitchen? So the kitchen window will be open. So there is, I mean, most welcome to modify. And what about all these people? That's the majority of our population. We should look for solutions while modifications to the building code are done. But we should also do other things. That's all I'm saying. And here, some typical observations, my observations from India. At 1 o'clock, you go in front of any school in Delhi. before the school is closed. Schools typically close at 2 o'clock. There's such a traffic jam. Everybody is honking. And the horn blazing away in front of the school are much more than on any average road. I happened to be in a hospital. I had an angiography. I was in the ICU of one of the top hospitals in Delhi. We had the noise inside. There was no traffic noise. It was just all the nurses and employees talking, shouting at each other. So then, there was nuisance. Already point has been raised about so many appliances working in my house. Municipal van. There's a municipal van which comes at 7 o'clock in front of our house every day. It has a loudspeaker and it plays filming music to us to attract attention. And then the message comes. Please come to your screen. So this is my last slide in 1 minute. My main point of today's lecture is that all these things, irresponsible blowing of horns, in any country, I have been to China, I've been to Japan, Europe, Indonesia, I have lived. You never hear a car horn. You can live for 5 days, you will not hear a car horn. It's only for emergency. It's a typical Indian problem. Whenever I come back from abroad, I come pick up and it lasts for a week or so. After that, I already want to. Similarly, a huge number of people living along railway lines in Judy property. Railway horns. The activity of railway horns, I will not spend time. Now, metro. What is this point? When a metro train enters the station, the driver has to blow the horn 2-3 times. Very often it happens, I have noticed. Not always, but very often, because people are standing on the edge of the platform. And the metro has a typical car type of horn, but much louder, and totally over the edge. At least Indian railway horns are somewhat edge. They are on the edge. My main point, ladies and gentlemen, is these are typical Indian problems. These do not occur in Japan or in Europe or in South Korea. So those companies are not going to find solutions for you. If you take the stand that the horn in my car is like this because the same car is made in Korea, it's made in Japan, it's made in Europe, it uses this kind of horn. But none of them have this problem. So these are typical Indian problems. The solution has to be found by Indians in India. No Japanese or German company will work on directional car horns or directional horns for the metro because they don't have a problem. It's our problem. We have to solve it. Thank you.
One or two quick questions, please. Okay. So there is a very valid point actually. But on the contrary, there is another important aspect because I've been in the committee for noise pollution. So now I think 2 states in India, Tripura and West Bengal, they are having the that sound limiter should be installed on the place. And this is eventually this will be coming to Delhi also. So maybe from manufacturer side, it's a different perspective. But when it comes to enforcement and administrative bodies, they have a different opinion because last 2-3 months we have been seeing this political issues in Maharashtra and all. So the only solution that administrative bodies feel is that installation of the loud sound limiters can solve it.
You can start selling now sound limiters.
I have my views, but I will not.
But on the contrary, I'm just, this is my personal view, that the manufacturer perspective should be also taken into account because the technical intricacies about this thing should be also taken. And maybe if sir can share with us some of the technical issues, like today he has shared, maybe we can take up more things with the authorities also that this is another aspect. Apart from sound limiters, you have to focus on engineering design also, like the column speakers, the line speakers, so that we can get more.
We'll discuss sound limiters, but not yet. I mean, less time is.
The other thing that you were saying is also, on the, you very clearly know that between 8 to 3 kilowatts sort of itself. So there's no sense in having a horn at 500 hertz because to get that same level, you have to make it at 80.
My main point is that if you are willing to increase the frequency a little, a lot more directivity can be made.
Okay, thank you, sir. Mr. Ikela, he focused mainly on two issues. One is unnecessary noise, and second is it has to be focused. So around these 2 points, the total talk was
For India,
for India. Yeah. However, it's a requirement because many times, if you remember, in school times, ring, bell, hooter was there, but nowadays it's very less. The pitch is low, and even in universities there is no hooter system. You see your watch and go move accordingly. So it is our mindset. As I said, in the railway station or in the metro, so continuous announcement. So that is required because nowadays our young generation they are busy with the earphones. So they are not listening at that time. They are listening at the last moment. That is why those kind of
And
things.
video display is better.
Yes, display is always better because now in the categories, the people, those who are traveling, one is well qualified and few people are not qualified also. But they will not understand English because most of the time the announcement is in English. In Hindi. Yeah. Okay, so that will help them. Okay. But to remind them at the last minute, so that you have to take care of all these things, and then after that they are comfortable, they will finish their journey. So let's thank again Mr. Ikela for his innovative talk. Thank you. Okay, thank you, sir. Thanks a lot. So our next speaker is Sahili. Okay, Sahili Goswami is an architect and holds a master degree in building engineering performance from CEPT University, Ahmedabad. He is currently leading the building science team at St. Govind Research India and is involved in measurement and simulation based assessment of building environment. She is heading project partitioning to multi-comfort analysis, thermal, visual, acoustic, etc. So now I request Ms. Sahili.
Hello, everyone. I hope I'm audible.
Now audible.
Okay, great. So hi, everyone, and thank you so much for introducing me, sir. So I would continue and I would give a first brief about our team, which is the building science team in St. Govind Research, India. So here in our team, basically we are working about the built environment as a whole. So where we are looking at the parameters, the multi-comfort parameters which are existing in a building. So we start with the visual comfort, the acoustics comfort, thermal comfort, and indoor air quality. So these are essentially all the parameters and verticals that are affecting the occupants in the end. And we are also trying to map its impact on the people. For instance, how are they perceiving it, and how is the comfort levels affecting their well-being. So this is the kind of overall thing that we are doing over here. And of course, energy performance is one of the most important factors that we quantify. And how we do it, what we do is something that I would briefly touch upon. And then I would talk in brief about the acoustics comfort work, the experience center that we have in our office. So here we have, since Saint-Gobain manufactures different kind of materials, our sole aim is to understand its impact on buildings. So we take a macro to micro level approach. We understand the overall buildings, the impact of materials once they are installed in them, and how is it interacting with the external climate, and as well as in the internal space usage, like how the people are using it. And in the end, how is it affecting the people is also extremely important, because eventually it's all about the occupants and how are they perceiving it, be it acoustics comfort, thermal comfort, visual comfort, or any other vertical that we are speaking of. So how we do it, there are three main uh, categories on which we try to quantify our analysis. So it's a complete data-driven approach that we take. So first is to use the simulation methods. So there are various different ways how we can quantify the energy performances to see the temperature changes in a given building in the floor plan, how the lighting levels are changing, how the acoustics is present in the given space based on the type of materials which are used, and the air quality. And not just through simulations, there are also multiple measurement related methods that we take up, both on the spot as well as continuous wireless monitoring is something that can be done. And lastly, and most importantly, to see its impact on the people. And this is where I would be talking in detail about. So we have created an experience center in our research office. So this basically allows the end users to come and feel the difference in terms of the acoustics performance of materials. So it's more like, so we have all the technical details and we do speak in terms of a lot of numbers, but eventually it needs to be translated into something which is easily conveyable to the end users and the end clients. So based on that, I would now delve more deeper about our room acoustics characterization system, or the RACS, or we simply call it as an acoustics experience center in simple words. So this was done in collaboration with JOSTS and Modalicon, and they greatly helped us in setting up the entire center, and how it has, I mean, it has been up and running for the past couple of years, and has kind of helped the end users to see how to perceive the acoustics. So to give a brief introduction of our entire setup, so I would just speak about it in a very simple way. So here we have 4 rooms which are placed consecutively. So they all have different kind of finishes, both in terms of walls as well as in terms of ceilings. We are using different type of materials having different type of acoustic related properties that is greatly affecting the kind of quality, the noise quality which is experienced by the people inside these rooms. So it's a completely calibrated and automated system that provides the output in terms of simple reverberation times and the sound transmission loss numbers. So there's a complete dashboard which has been created, and we let the users themselves come and control it. So there are different controller systems that can help to kind of generate the noise source, and then to calculate the reverberation time, not just to look at it as a in terms of numbers, but also to experience it themselves by standing inside the rooms. So these are the 4 places, and these are the key, these are the details of each of the wall finishes that are given in these respective diagrams. And all of these rooms can be individually tested. So for example, if I want to see the RT levels in one room, I can do that. Or if I want to look at all of them together or a couple of them, let's say 1 and 3, Even that can be done using the given setup. And to speak a little more about the details of the material now, what kind of combinations have been used. So in room 1, both the wall and the ceiling is treated. So in the wall, we have the Quattro system that has a fairly good NRC as well as STC values. And the same thing goes for the ceiling treatment as well. So we are using 6-toe, and both of them have perforations that can help in providing better acoustic properties to these materials. And the walls which are treated, so on the right, you can see there are 3 partition walls which are present in the complete system. And so the treatment is only given on one side of the wall for each of these given systems. And then similarly in the second room we have ecophone. So these are the wall ecophone panels which are installed on the wall. So this is again to kind of
Hello.
hello. Hello. Yeah, sorry. I think there's some network issue. I'll reshare my screen. Is it better now?
Yes. It's okay. Yes, fine. Go ahead.
And then similarly in the second room as well, we have the ceiling treatment, which is again of which is Ecophone Focus A ceiling tiles. And then similarly in the third room, we have kept it fairly simple. There are only brick walls which are there, and the ceiling treatment is done with as a plain ceiling, which is being used. And then in the fourth room, there is chip wall quiet, which is further treated and has a very high, a very better STC value. And same thing for even the ceiling is treated very well with a high performing material. So eventually what we are able to get is 4 different type of scenarios in 4 different rooms. And that is allowing the people to experience the difference that a material can make. So what kind of systems are we using? So the entire component has 5 different type of setups, 5 different components. The first is we are using a sound level meter, an SLM, which is from BNK, and this is essentially gathering all the data and is converting into, so there's a dashboard which is integrated and that converts and helps us to plot and view the RT levels and the reduction in decibel levels. Same, we are using Raspberry Pi setups. There are speakers to generate the noise source and microphones to kind of gather the inputs. And similarly, we have each of the rooms have a kind of display setup that also helps to view the independent acoustic performance of each of the rooms. In terms of the system architecture, we have the following setup. So on each of the room, as I was mentioning, there is one master. There is one master. Sorry. So there is one master. Hello. Hello. Am I audible?
Yes, yes.
Yeah. So in each of the rooms we have a client Raspberry Pi, and then there's one master Raspberry Pi which is installed, which kind of is gathering all the inputs together. And in each of the rooms we can, as we can see over here, there is an independent television screen that helps us to view the results. And similarly, there's one consolidated one which is there on the outside that helps us to see. Now, I will show some quick examples of how the results are looking like. So under the sound absorption test, this is how the entire dashboard is. So these are the 4 rooms that I was mentioning. You can select the room where you want to take the tests. And on the right, we have 3 options for absorption, isolation, and for speech test. So absorption and isolation have more to do in terms of giving the quantitative numbers in terms of graphs, whereas speech test is more like qualitative, where we can allow people to go inside the rooms and experience the noise levels themselves. So here, once we are selecting the room, and here we can also, for the RT test, we can select the kind of noise type. And then based on that, it calculates and plot and provides the output like this, where across each of the frequency levels, it will tell the RT values. And then there will be one single number that the source can provide. So the microphone is suspended in the middle of the room, and that's where the values are being analyzed. The same thing if we have to do kind of for multiple rooms. So here we can make the selections for all the 4 rooms together. And the isolation numbers can be viewed like this consecutively all across. I mean, they can be seen all together so that we can see how each of the rooms are performing in terms of the RT performances. Now, similarly, in terms of isolation, we can in the same way we can do it for individual rooms as well as all of them together. So this is an example of doing it all together, and since under three, there are total 4 rooms, and of course it has to be done for the 3 partition walls. So this is how it can tell how much of transmission losses are happening through each of the walls. So here for each of them, the value, so these are some sample values that are being shown over here. And this is how the entire system is working. In terms of speech test, this is where the occupants can go inside the room and can experience the difference that is happening in because of using these high performing materials. And here from the drop down, one can select the type of speech. And then this is like a simple output that is shown in the dashboard, but it more has to do with experiencing it while being there inside the space. So I think this is it. I mean, it was just a quick kind of introduction to the kind of setup that we have over here for the experience center. Thank you.
Yeah. Thank you, Charlie. So, can I have questions? Yes.
Any questions? Thank you, Dr. Shelley, for your wonderful talk. I have just one question.
Yes,
Hello,
sir.
am I audible? Yeah.
Not very clearly.
Are people perception also and correlating it with the noise level?
I
Hello.
couldn't hear your complete question. I heard the word people perception.
Whether you are trying to correlate the perception with sound insulation or just with the noise level?
So currently we have done it just with the noise levels. So there are a lot of so we are planning to do another set of cognitive studies. And the ones that we have done so far, they clearly show that there is an impact of background noise and the ambient noise levels on the perception of people, their ability to concentrate. And also, it may also create some issues, like in terms of the ability to focus, or even in long term, it disturbs the sleep of people. So there are multiple correlations that we have done. But I think in the future, we are also trying to do it, taking more parameters into account.
Okay. Thank you, Dr. Shah.
Thank you.
Okay. Ms. Shelley. So I have another question. So you have shown 4 chambers. So these are application based or it's in journal. I think it will be better if it is customized, maybe for studying, for hospital or at public place. I think that will be more beneficial, and the public will be attracted by those solutions rather than we are saying these are the 4 solutions for what.
So probably my presentation will cover that.
Okay.
Yes.
So in your case, do you suggest anything?
No, what she has presented, that is there available in the
Whatever is available. Whatever is available.
Now what we are doing, we are extrapolating those ideas and taking some of the ideas to the field. Probably in one slide I will present.
Okay, application based.
Application.
Okay. So
Similar to that. Yes.
okay, so this is also good. So thank you, madam. for your innovative talk. So I hope that in future you will be doing well and coming up with better solutions also for the sound absorber. Thank you. Now I request our next speaker, Mr. Rajiv Chaudhary. So I think he can introduce himself, so that will be better.
It's too much of technical. So let us make it a little fun filled. So my name is Rajiv Chaudhary. So I studied in Nagpur and then I did my post from Bangalore. I've been working with Symbogen for last 15 years. Currently, I'm based at Delhi, General Manager, North Delhi, and I'm also responsible for the filling business. I'm the head of filling business for Symbogen. So that's a small introduction of so that's how I'm presenting myself. So the theme of today's presentation is growing. In fact, this is a thing that as an organization, we are driving globally. So not a very technical presentation. I mean, it will be kind of what exactly we are trying to do, what kind of solutions we have, and what we are doing, trying to do for the industry, and the limitations that we see from the industry. I think I start the presentation that while I be representing the guideline of NBC, but the unfortunate part of the story is that these are not mandated. These are all voluntary, these are recommendations. But whenever we see any global client comes, they ensure that all the receivable levels, evaluation time, those things are actually being implemented. So about the acoustics, there's a subject. So I will touch base the NBC part and the challenges that we face in touching cases. So this is the company that I represent. It's a French company with only 366 years old. When I say 366 years, it is as old as Taj. So we have got around 1,500 companies with Symbogen, and in India around 8 or 10 companies are present. So large company. So everything is written here. The important part is here. The 12% of Fortune 500 companies, this after 1955, still present, which means that we are an innovative company. We want to innovate, and we want to innovate for the globe, for the world. So that being said, this is what we do for our stakeholders. We are present everywhere. We are present in the exterior part, we are present in the interior part, we are present in the ceilings, different types of ceilings, and our core business is gypsum. I think I was very happy when Dr. P was talking about his association with India Gypsum. So when he talked about how, as an organization, India Gypsum started talking about gypsum and then reaching out to all the stakeholders and showing that this proper installation is done. So I mean, people like Mr. Shruti talking about our company, it matters a lot. So now I think my colleague Naresh nicely presented, he shared a case study of a school, where he wanted to showcase that a teacher, they try to speak because louder, because the student who is at the, sitting at the last bench, probably he or she does not understand because the sound travels between 80 degrees. These are the common words. Whenever we go to architects, go to the consultant, we come to NPL, we only talk about all these words. We talked about sound, we talked about echo, we talked about this reverberation time, NRC, it's a very complex subject. When we talk to the architect, the customer consultant, they have a very different perspective about this sound, typically the building acoustics. So these are the particular terms that we every day we encounter. But there are many companies they will talk about only there are some companies will talk about SC. But whenever you go, I think the reverberation time is very important. So that's how everything is this. So I think this is something I will not touch upon because all of you are this master of this subject. It's something that I will be getting into your shoes. This is the project that I will start with. So what share is that sir, you also said that this is something is there, this at your left. Why don't you take it to, this space or, real life kind of an example. So this is a kind of data project. So this is a project where, this the client came to us and they wanted to understand that what kind of problems they have and what kind of, the support we can expect. So typically, if you look at, so the problem statement is that there are a huge amount of, this sound insensitivity or sound diversion time issues because there are a lot of noise, a lot of echoes. So they wanted some kind of support, some kind of solution from us. So these are the areas. Typically, this, as we are talking about building acoustics. So in any office or any school, any auditorium, any place, I think these are the largely, 6 places where you see that you have some issues or you encounter some problems with respect to, the sound or acoustic or reverberation or we can change everything. So auditorium, boardroom, cafeteria, conference hall, meeting room, and meeting room 2. I think my colleague Shelley talked about what all these instruments we use as in our friend. They supported big time those in terms of installing the vision at our SGRI center. So this is something this I think all of you must be knowing about it. Here is the this is the project description. Now if you look at here it is the reverberation time that NBC typically talks about. And this is the actual site condition. So boardroom, the current RT level is, the existing RT level is 1. Desired level as per NBC or OL is around 0.6 seconds. Conference too high. Target area as per the guideline it is 1, but the current level is 2.6. Like that. Meeting room 1 and meeting room, I think fairly okay. So we thought of that, okay, there is no requirement of giving any suggestions as because it is well within the limit that is prescribed under NBC. So let's look at the challenge that we have encountered in the conference room. So special average is 1.6, which is very large. So we have talked about these different points we go and we take the measurement. So the average is coming up closely 1.67 seconds. So typically what we have observed, in fact, on a lighter note, if you look at this room, I should not comment, the hard surface, it reflects, hard surface is reflects, hard surface reflects. Only probably or absolutely material I see is the cartoon and not the chair. So it happens, there's many times you see that because even if you want to do something, but I think in practical scenarios we can't do it. Look at the office, it is all hard surface. If some top, if some board does not give you any enough, you need to have some explosive material, a combination of the material that gives energy so that you get the required revolution time in the room. So we have looked at everything, and then as I said, the average was coming out to be around 1.6 seconds. Fine. So obviously, then as per the guideline, it is coming out to be, this fair. But I think what we wanted an excellent kind of a solution or the space. Then what solution we have given? We have given some solutions. We have product solutions in the form of glasswool. We call it solo. So given solution for the ceiling, and that takes care of the absorption, as well as we have given some wall panel, so that there is the reverberation time of the room that it falls within the desired. Correct. So the reverberation time, I think it reduced, and that fall under the the specifications that as per the guideline of the NBC. Now, auditorium is a segment where I think we have a lot of products. Auditorium typically, the frequency level is low. You need a product that gives very, excellent performance in the low frequency, this band occupant. So here also, if you look at it, this the auditorium, the question average is coming out to be 2.6 seconds. It's very high. It's very high. And so you can see the site condition of the auditorium. I think they have all around, these hard surface and their these tables are, these wooden tables. They do not have any absorptive material. So all around, I think it is the, this reflective material. So as I said, the walls concrete, the floor concrete, ceiling concrete. So I mean, hardly there are any material that can actually absorb the sound. And this is the reverberation time RT was too high. So we did simulation. We have got this software and this platform where we can look at the problems and then probably provide or suggest what is to be the suggested material to be used. So again, this as the reverberation time was too high, it was actually poor and bad, but we wanted something for that particular space which will give kind of a good kind of an environment or interior sound ambient kind of an environment. So now from a level of 3.9 reverberation time, we wanted some solution, and the solution was given by us. So it is a combination of again some solutions which will give 0.7 NRC, some perforated system board, some wall panel of 0.9, and also some solutions of the solos that is close to 0.9 to 0.9 NRC. As a whole, this is combination of products. The placing of the products are important. The density of the products are important. So with everything, I think the overall the reverberation time that the client wanted was coming out to be the same way. So this is the and the third area where the same client wanted some solution from us for the cafeteria. Again, this, if you look at any cafeteria, you happen to be any, if you go to airport, all there will be noise, but typically the cafeteria, you see a lot of noise. If you happen to be in any IT office, you'll see that during, this lunch or, maybe during 5:30 or 6 in the evening, huge amount of, the employees sit and the noise level is too high. So I think cafeteria is one of the areas where I think we need extremely good, this sound solution so that the reverberation time is well maintained there. Again, you can see the cafeteria, I think the reverberation time is 2.7 seconds, very high, very high. So literally everyone will shout, everyone will shout, will not hear anything. So there are 11 measurement points, and the reverberation time, this you can see from 2.5 to 2.75, 2.8, is too high. So it is 2.7 seconds. Again, this is the material. Currently the materials are very different material. Most of the materials are reflective material, hardly any material, this that are of absorptive material. Hence, the reverberation time is too high, and hence the area is too noisy. So again, we used the software that we have, and then we looked at, this SCI, and then we suggested that this is a very, very poor condition, and we wanted to have something that will give us a solution that will be good or fairly okay kind of environment in that particular cafeteria zone. So again, we suggested different products. We suggested the combination of glass wool products. We suggested combination of products that goes on the this wall, which takes care of this some of the noise that there is inside the environment. So overall, I think this is a combination of the glass wool and perforated board that takes care of the reverberation time that we wanted for the particular space. So that's how. So I think the reverberation time from a level of 2.6 that got reduced to 1.6 seconds, and this is again as per the guideline of the NDC. But as I said, this is the beginning of my presentation that NDC guidelines are the nice to have, but I think hardly there is any representation or these are not mandated. Unless otherwise it is mandated, I think NPC's guideline may not be, this is taken up by most of the builders seriously. So now, just to summary of all the groups, I think because, as I said, the meeting group 1 and 2 does not require any services or any support or any solutions for acoustics. But for cafeteria, conference group, and auditorium, huge amount of this deviation is there. I think we have suggested whatever is required to achieve the result level of evaluation time. Now, ceilings, what all products we have? I think we have got again, these products and solutions starting from 0.7 to point NRC, but 0.7 and point NRC is misleading. We have combination of products that can get you, this kind of a evaluation time that you look for your building space. These are, high-end, extremely good products of corporate discount board. They are, we tell that more than aesthetics, more than acoustics, they are aesthetically appealing product because you can paint them. Because it's a gypsum product, you can band it also. Any architect can play with the 3D with the product. So these are the products and solutions that we have from Silco Band. That's all from me. Thanks a lot.
Yes, sir.
Reverberated time is a very common parameter, very much needed. I also saw mention of STI, which is what I was asking, but which is not there in the CI export. And with two other manufacturers, I think, say that it is a very important parameter, right?
Yes, sir. I think it's important. So, see, as a manufacturer, there are a lot of guidelines, but I think that time it is not mandated. It is not mandated by the government, by by the government body. I think it's very difficult for us to make sure that it is. I think it is nice to have, but it's like you have got a need in your house, but if you don't use it, it doesn't make any difference to you. Something like that.
Yes, sir.
I am working on the aviation sector. Working there. Basically, I was looking for good. I think in a small or a micro level or a small level. Do you have any anything or anything done, research done? How to reduce the noise level in the airfield area? If we say an airfield area, like the Delhi airport, and as I believe, as the colonies came up, wasn't good Volga or not claimed to be living on water, but they are all in a horrific condition. We have observed because of our background and we have. Do you have anyone done any research on this? And also, what type of intervention one can do?
So I'll talk to you. I'll take your number and take it up. Obviously, we have got an R&D at Chennai. They do a lot of global projects. Okay, so we have got R&D globally. India R&D takes care of around 18-19 countries. So for sure, I think somebody must be working on that. I will take your number and then.
Center at the IIT Madras.
Correct.
Are they involved with it?
They must be. They must be doing a lot of projects, including some of the projects. These are common projects. Absolutely. Happy to work with you. I will take your number and cards and show you. Take it. Thanks a lot, Doctor, for giving this opportunity. Nice.
One moment to get.
So, thanks to Mr. Rajiv for this. We have given some solutions for in a customized way for railway station, for auditorium, and so on. So, according to that, yes.
I think the point that you raised about airfield, the similar problem came to us in 2009 when this runway 29 was a huge issue because the people nearing there was a spinal injury hospital actually. Yeah, Vasanpur. And those people were really after this GMR people that what should be done, because while landing, there is a reverse thrust done by the aircraft. And that reverse thrust is creating a lot of problems to the nearby people. But eventually when we try to analyze those, all the people, those who are having their houses, those are mostly the farmers. And those farmhouses belong to the very high class people. So it was just maybe a political issue also. But then Delhi High Court also intervened in that, and they asked an expert committee for that. Ultimately, there was no solution, because ultimately you have to improve the sounding solution of your home, because there is no technical solution for particular aircraft if you can control. Or like today Gautam Suri sir told that if you erect a wall of 5 meters, then also there will be no solution. So the only solution lies is I को उतना अच्छा insulation करूँ ताकि I can protect myself.
Yeah, my flat is right in Bonaka. That is King MP. When I went to 20 years back, I even taken care of the but the new runway which came up, just
I think this problem will be solved next year, because just now, a few days back, there was a newspaper that a new runway will be operational next year, and it will bear the load of these 3 runways, existing 3 runways.
actually you will find the problem to 2 areas.
Maybe that would be one perspective, but eventually it will.
One more solution is no night flight.
Yeah, that was also there. That was also there. 6 month night curfew was there. But yes.
But why Europe and USA have that rule, and why we don't have? Because they are third world countries, right?
There are smaller countries that they can afford to do that. Okay,
We are first world, we are third world. इसलिए हम
domestic airport they may be.
once our GDP is $26 billion, we also have no price limit.
Okay, thank you, Topic. So our next speaker is Mr. Sandeep Mittal. He is from Anton Acoustics from Bangalore. So he is a technical director of this industry and building acoustics industry since 1990 for last 30 years. In last 90s, after attending International Acoustic Conference, he left the big gap in India and formed Sandeep Acoustics. Right.
Thank you, Professor.
So little bit he will tell about himself. Thank you.
Thank you, Professor Ravindra Agarwal, for the introduction. I'll continue on my note. Thank you, Dr. Naveen, for the opportunity to not only be present here, but to be on this stage and to share my thoughts. As Professor Ravindra Agarwal said, I've been in the industry for 30+ years. So there are some perspective, some insight, some experience of the industry and the subject. So it's good in one way to have me in the last workforce. I can see the hall is less attended and they're less online also. But I can kind of wrap up on the subject. So as you were saying, I've been associated since 30 years, and in the late 90s, I started to attend international workshops and conferences on acoustics, hosted by Acoustic Society of America and all those international societies. So I felt there's a gap, and so I founded Sound Design and Acoustic Design firm, and wherein we brought in modern methods and acoustic instrumentation from JOS this year. We were the first in the private sector to invest into spectrum analyzers and omnidirectional loudspeaker and even the tapping machine for throat noise control in the late 90s, and which I ran for 15 years. And apart from that, the knowledge on the materials and knowledge on the acoustical sciences, right from the 1990s, being associated with Professor B.S. Ramakrishna at Indian Institute of Science, Bangalore. Very few would know because you're from the next generation, but you will know. Yes. And with Dr. Mohanan at NCL in Delhi. U.S. Bhargav was there in those days, K.L. Malhotra from Prasad Bharati, so on and so forth. So that is the background and that is the perspective. So keep it short, get into the day and some brainstorming too. The acoustics
industry in terms of acoustical material is still at a stage where it has not matured. And you have many instances of acoustical practices not being in tune with the international standards or even with the Indian standards. So my appeal to NPL and to this workshop stakeholders is that we need to ensure some framework. I don't have a solution because I'm one of the product manufacturers apart from acoustical designers. So wherein all product manufacturers can be brought on a common platform, or at least they operate under a standardized framework so that it is easy for architects, end users, departments cannot get confused. Further, as it is, acoustics can be a confusing subject because noise isolation, as in terms of SPC and dB level, is confused with sound absorption and NRC and reverberation time. Architects, especially the layperson, they don't understand these concepts. So it becomes important that there is a standard format, standard framework, and some kind of standardization among the acoustical material manufacturers in brands. This subject has not been spoken of. What I'm trying to speak about and propose to NPL and to other state leadership in trying to get a framework. There are standards and there are such frameworks available from the first world, from where you can learn and feel inspired from North America, Europe, and we can apply them to India as well in our own way, as India is developing and aspires to be a developed nation soon, right? So this was one of the points I wanted to bring out. Secondly, the BIS CED section on acoustics again focuses on a few aspects of architectural acoustics, some standards, but not on acoustical, not on spaces like, for example, schools. There is a standard ANSI S12.60 in North America, USA, for example. This is only for schools and classrooms, and it is a pretty elaborate standard. Whereas here we find one small paragraph mentioned, but that is not enough, I feel now. And everybody, most of the speakers preceding me have spoken about schools being a center of learning, and hence the spoken word is very important. I can give an example of Bangalore, one of the best schools. My daughter now, she's passed out in architecture, but when she was in high school, the rear of the classroom used to face the road traffic. So every 1 week, the students were made to come to the front, and the front row will go back, and they will shift the students so that everybody is not in the noise all the time. And this is so ridiculous. From the top schools, good fees, they can even go for some more fees or some more fundraising, but that consciousness, that awareness is not there. The importance of acoustics for learning in the classroom is not there. So again, I would request that role comes in of NBC in terms of the standardized standards committee and NPF to take this thing forward. And as my previous speaker, my colleague from Ken spoke, that this has not been mandated. It is just NBC is only advisory. If it can be made more, not a law, at least can be made more nicely, or CPWD and the state PWDs, they take it up more seriously and start to specify these codes in their project specifications. Where we find the loophole is that there are not very strong specifications based on standards. That's the first loophole. Second loophole is the L1 system, wherein the lowest bid contractor wins the contract and then he begins the shortcuts by having his connections in the department. So if these specifications are rigid, and it gives an equal playing field to those who meet those specifications. It doesn't have to be a one-time specification. If the specs are strong, based on standards, and give a level playing field to a few or who will meet those standards, then it will go a long way in addressing the manufacturers that happen at the end of this value chain. Here we speak very well. Here we speak a lot of good intent. But and also at the stage of designing a project, at the stage of the architect, everything is nice and, things feel good. But when it comes to implementation of the project, and I'm talking of top projects, I'll give one example without taking names. Example is ITPO, that name I can take, wherein the acoustical material is, which is being used finally is perforated plywood. Plywood perforated by the contractor and brought to site and installed. There is no NRC certification for that. It is just random holes on plywood. I hope that plywood is FR rated at least in terms of fire safety. But project like ITPO, which is now a PMO monitored project, which is going to host G20 next year, has got acoustical ceiling of perforated plywood perforated by the contractor at site or in the factory, not having any acoustical certification. No, initially the specs were very nice. As I just spoke, one of the top architects from India and from overseas have given the best of specs. But when it comes to L1 and the final, these shortcuts begin to happen, which is something which has not been addressed. After any number of workshops, any number of seminars, and NSAs was there early on. So what I'm saying is this practicality has to be addressed. Otherwise, the end user is not getting the experience that we want them to get. And it can also be a safety hazard. Maybe ITPO is using FR rated, but I've seen any number of auditoriums in India, especially government auditoriums. Government means state government and central government, which do not follow FR standards for acoustical material. And ultimately, in an auditorium, the entire wall paneling and the ceiling is acoustical, right? It is the largest surface area in an enclosed space where 500 to 1,000 people are sitting. And if the acoustical surfaces are not FR rated, you can imagine the risk it can be to the, and we don't know when it may happen. Maybe it happened 30 years ago at Bhopal fire tragedy, 1 or 2 happens every 10, 20 years. But public memory is short. So this is where fire rating also comes into play for acoustical material in enclosed space. While this is a building acoustic workshop, the importance of fire rating cannot be overemphasized because we are dealing with enclosed spaces. We are not dealing with external spaces like road barriers or with community noise or like last time I told about Shamiyanas having noise barriers. So it's outdoor. We're talking about indoor spaces, large spaces, large number of people are sitting in a dark environment and where anything can happen. So, fire rating of acoustical material should be a point to be noted for adding or for at least, for implementing. More than adding in NBC, we should be implementing in the project specification and keeping to those specifications. Similarly, like fire, there is HVAC noise control, wherein you can install the best of acoustical material. Your specs can be modified, and the contractor will implement them. But if HVAC noise control is not considered, there can be noise transfer between enclosed spaces, between 2 rooms. Just example is New Parliament, the translation booth. The translation booth in the NXT building of the New Parliament coming up. Fortunately, we were involved, so we are getting the noise isolation partitions of our MGO board, and we are giving sound absorption. We noticed the HVAC ducting is passing over the booth instead of passing from the corridor and each booth getting a branch duct. They had already designed and implementing HVAC ducting across the booths. Then, because we were talking sense, we were talking logic, they understood, and capability from the agency. Capability got it changed because it didn't cost much to shift it small with common sense. So HVAC noise control, fire rating, these are allied subjects with acoustical materials for enclosed spaces. This should be considered. It has not been talked about. The additional point that I'm adding. And gentleman from Abuja, Mr. Nal, he talked about audio. So he spoke very well, and I'm happy that somebody in India, from India, made in India, is so technically and so sound on the subject. So audio should also be considered while designing an enclosed space, because acoustically and audio, acoustical sound absorption and audio reinforcement goes together, both complement each other. I've seen any number of spaces in India that are designed in isolation. The audio waterproof area and acoustic waterproof area. But what is the loudspeakers being installed? What is the frequency response? What is the dispersion angle? What is the mounting method? How it is directed at the audience? Is it directed or not directed? What will be the play of sound on the surfaces, the floor, the walls, the ceiling? It's not considered. So just made to design blindly the acoustic of the space, the hard surface है, वो hard है, but audio कैसा है? वो तो देखना चाहिए. And there are audio companies. Thankfully not Abuja, but there are audio companies, major brands of the world, which say that we will be in the sound. We will direct the sound so well that you don't need acoustic. हमारा महंगा है, but you can take ours because you will save on acoustic. Now you can beam, as you said, high frequencies, small wavelengths. How do you beam the smaller, the low frequencies, larger wavelengths with anyway going still through the walls and the ceiling? So fire ratings. What did I say? Fire ratings. The audio system, HVAC noise control. This should also be considered along with acoustical material and all the other aspects that came up, and all the points that came up, for giving good spaces to people of India now. The rest of you have the latest phones in India, you have the latest vehicles in India, SUVs, limos, sedans. You have the best of everything. You aspire, you see the world. I mean, you travel the world now. I'm talking about middle class, upper middle class Indians. You go to malls in India, you go to cinemas, you go to public spaces, airports, everywhere, and you do deserve the best as well. We Indians also deserve the best. So we need to incorporate. It doesn't take much, doesn't cost very much. Just creating awareness and creating that narrative that everybody can join hands and follow, and make sure that India also is at par. It's not at par, at least somewhere there, in terms of acoustical spaces or acoustic in enclosed spaces. So I heard a lot of talk on the noise pollution and outdoor noise, but indoor noise pollution, I can tell you, is also a subject of concern. Just like outdoor noise pollution has been the subject of this workshop, has dominated this workshop, but indoor noise pollution, as in echo, as in sound reverberation, as in noise in general inside the building, should also be just which has been discussed to some extent. But indoor noise pollution should come on people's lips. I mean, it should be a talk, should be a term that should be also used along with outdoor noise pollution. People have spoken about NRC and STC, and of course the importance of frequency. Again, NRC 0.9 चाहिए. NRC 0.9 has become like a holy word. NRC 0.9 क्यों चाहिए भाई? वो NRC 0.9 में frequency behavior क्या है? Two materials can give 0.9. One can be good for low frequency. One can be good for high frequency. Both can be 0.9. So 0.9 to beyond we have to go now. 0.9 is too basic, and frequency behavior is important. And you may not even need 0.9. For a seminar hall, you have directivity of the natural sound. You don't need 0.9 because you need to reflect also. There's something called beneficial sound reflection, apart from sound absorption. So only where sound absorption is required, go for it, and where you require sound reflection, we should also think of that. No study is done on the benefits of sound reflection. You can save on even the loudspeaker power. You can have lower power loudspeakers if you can have some sound, beneficial sound reflection in enclosed spaces, apart from sound absorption and sound diffusion. So, 0.9 NRC is just an abused word. It's hardly understood word, and it's a much abused word. Or term. Sorry? Over leverage. Same way FCC 50. Similar to a 9-inch brick. Actually, FCC 50 came up from a 9-inch brick 50 years ago, 70 years ago. So, you need to study that. Why do you need? Suppose you have STC 50 walls, but your door is STC 30. You are going to degrade the overall noise isolation of the space. If you have STC 50, everything has to be STC. It's very expensive, not practical. So why not go for STC 39, 40? So more practical in terms of power, in terms of HVAC noise control, in terms of, again, STC cannot be considered in isolation. It matters a lot. Any open space, any open window, doors, conduiting, penetration in the wall, HVAC, ducting, all matters, all contributes to STC values of in terms of background noise of the room. And lastly, performance. We have spoken about reservation time, and this you also mentioned briefly, but you should not focus only on NRC and STC of materials. You should also focus on the performance of the space. How much reverse time do you want? Even NDC talks about ideal reverse time, but doesn't talk about the volume of the space, because reverse time is a formula, Savant's formula based on volume of the space. So when I spoke about ANSI, ANSI S12.60, in that clearly is mentioned, if your classroom is 500 meters cube, this should be the reservation time. It is 1,000 lecture hall. Nowadays, now every state is getting an IIT, every state is getting an IIM, and so on and so forth, NIT. It become a political competition. So there are large lecture halls, there are small classrooms, there are all kind of places. Wherein I see a very basic approach to acoustics for all these places. Whereas these are the temples of learning, and these are the torchbearers of India to the world. These should have been designed in a world-class fashion. So these are some of the thoughts I had. I spoke mostly extempore and wanted to hear to hear. This is a building acoustic workshop, so hearing was important. No PPT to present, but I'll take any Q&A now. Any questions, please? Online also, you can ask anybody for questions. So I think if anybody wants to speak, they can ask questions, or anybody in this audience. And I think when we brought out the air conditioning, and it actually already has standard on noise measurement for. I know, actually all have, actually to have, but who understands this, first of all? Secondly, who implements it? Cost a lot, cost a bit more.
Sir, here's a valid point which I showed in my slide. The National Building Code doesn't mention about the actually, just touches about it, but there are, and secondly, the main issue is it talks about the NC rating. Now NC rating is totally abolished. Now it is NCB RC criteria. And ultimately, most of the countries, they are still using NCB, and NCB has a very flexible approach. It talks about the heat criteria, rumble criteria, the suitable vibrations, and all these things should be there so that we can investigate that how the HVAC system is performing. And if it requires any particular anything so as to modify that.
Why I got out to the point that your building consists of, as Mr. correctly put it, material, air conditioning, DG sector. So the building code should incorporate all the standards. So there is a standard. The noise fundamental. So if there is a standard for air conditioning also, that is part of the building code. There is a noise measurement, let's say now generator set. We are now installing microphones at the Microsoft Center in Hyderabad because they said that the DG set room noise level should not be so much that the operator is difficult. That means there is a standard somewhere, and that standard also now will be part of, building code overall. Same way, structural bone and airborne vibration and that standard, because you have lots of equipment in a building which could cause building vibration. So now, we would be at the AC noise or that, and in India you have a building problem. DG set. We don't have that in Europe and USA. In India, a DG set is sort of a default requirement. But then the moment you have a DG set, you have the DG sets now have enclosures. Yeah. No, but then you would have a problem sometimes. Yeah. Sometimes the door of the enclosure is left open by the operator. So that is not proper. The DG set room is fine. But the noise goes to the deck. That and you find a room near the DG set has more noise than the. This I want to add to what Dr. Garg said about NCB rating. So earlier we had NC, now we have RC, Mark 1, Mark 2, because
the whole subject of acoustics, including NRC and STC values, are based on 125 hertz onwards. At a time 70 years ago, when the propagation of sound through loudspeakers and other machines was such that low frequencies were not high enough, or not being addressed, or not understood enough, or because human ear is not so sensitive, so they thought it's not important. But now, there is a need to at least go down to 63 hertz, when I'm talking about 1/3 octave band, and so that 63, 80, so on, so that that can address the, as Mr. Lal spoke about 9 array speakers and other loudspeaker issues, where low frequencies are now being much more propagated, and the young and the youth, apart from the earphone, they like to get the thump on the chest. So vibration and low frequency sound, low frequency earphone noise that induces vibration in building structures.
In fact, the more
also important.
ISO 16283, the latest standard terms of measurement as per ISO 16283 at low frequency. And that is what some
LF is still less understood and less addressed. But let us first understand and implement the normal acoustical terms and in a proper way, and the acoustical sciences for building, and feel as a user, feel the experience, then we go to low frequency.
I think I would like to add one thing. Probably Sandeep sir has missed his introduction, but I just want to share with you that when I started my career in 2004, then we met at National Symposium on Acoustics at Mysore. So my predecessor, Dr. Mohan, he was there with me, and he told me, अब ज्वाइन यहाँ किया है तो PhD करनी है तो संदीप जी को पकड़ लो. He was at the, I think at that point of time he was at the very, so he was so well known in this field, and I think sir को शायद नहीं याद होगा, sir ने एक stall लगाया हुआ था. So I went to that stall and there was a huge bunch of papers where NRC values and STC values were. I asked one of the person from his company कि ये सब चीजें कहाँ से करवाई? बोला NPL से ही करवाई. So that was really very amazing to me कि अच्छा हम लोगों ने इतनी सारी testing की है. So I am very glad.
Thank you for that. And to add, we have always, from 1990, I went to a number of labs across India, some not working, some working, including Indian Institute of Science. The ECE department, this Dr. B.S. Ramakrishnan was heading, had a vibration chamber, but it was small. And then much later, ARAI, and before that even Prasar Bharati, which was then called All India Radio, had a reverb chamber. But when I came to NPL, I was really impressed that, they have these reverb chambers are made as per ISO standards, 250 meter cubes se zyada hi hai. So the volume is very important. The reverb chambers, the volume is very important. They are all isolated. You have been here, double walled, and they are so well isolated that I was very impressed. And then we found later also that NPL is the best when it comes to building material testing for STC or NRC values. We found NPL the best and very committed scientists. And now they have brought in ratings of ISO EN 11654 rapid testing. So they're the first again in India to do that, bring this innovation. So it's mutual respect, mutual love and appreciation.
We are very thankful to you that you have traveled from Bangalore just for this workshop.
Thank you. I'm honored and I'm privileged.
I think you are also the first people to use audio in the country.
Audio, yeah, we were the only use
What is the BNP?
BNC in the private sector.
While when we were doing a study on this voice control, I tried to get into the whole PhD topic done in IIT Chennai and NIT Delhi. I hardly found any particular person dealing with this particular thing or the variation. It may be a nice idea to experts like or experts in this. Certain guidelines to some of the policies. What certain studies done on us? Here to support. And it might help in mentoring, where unknown areas of this interpretation. That is a single time.
Sure, sir. That point we will discuss in this brainstorming.
Actually, acoustics and noise is invisible, so it's less aware. If you talk about fire, there is smoke. And also about pollution, there is, our lungs are getting affected. So that's the reason why acoustic and noise finds less more.
Thank you, Mr. Deep Mittal, for his innovative talk. So technical talk. So he has brief about the vision and the future of it. Thank you.
Thanks, Dr. Ravinder Agarwal sir. Ravinder Agarwal sir is always with us. I think whenever we are organizing our workshops and conferences, he's always there with us and he's supporting like anything. So I thank you, sir, for sharing the session. And I request Dr. Mr. Rashika sir to please tell it to. So I think we now wait for a tea and then after that we will have a brainstorming session. Yesterday it was really very enjoyable. People really we started at I think 5:45 and it went up to 7 o'clock. Yeah. But it was very interesting. Everybody we really enjoyed that session.
We didn't realize that the time reached 7.